how do we get from here, a context graph containing information about PC components, to a real life agentic workflow that's an assistant, agentic shopping assistant using that information, using all the properties of those components, using all the compatibility requirements of those components, and even using a budget specified by the user to a contextual decision traces. Are we really going to use that term? We'll see. That actually captures how the customer made their decisions. What were they shown? What were they not shown? What did they choose? Do we understand why they choose it? When are they choosing it? And trying to understand those trends and those patterns. Well, I'm going to show you that and a whole lot more today. We're thrilled, pleased. Wow, this really does sound like a press release. We're thrilled. We actually are thrilled to announce that we're going to be giving you free access to the TrustGraph Playground. Link down below in the description. That's right. Click that description. There's a link, and you too can get access to the Playground preview where you'll be able to test all of this. No deployments necessary, no API keys necessary. All you have to do is get some credentials, log in, and you'll be able to do all of this yourself. And oh, by the way, while you're down in the description, I guess click the subscribe button and click the bell. Do people actually click the bell? Do people really do that? I guess you're supposed to say that, though. The YouTube algorithm probably likes it when I say that. So do all those things. We really appreciate it. That way you'll know when we release more content where we talk about things like holonic context graphs. Ooh, what's that word? And talk about more features coming from the totally open source TrustGraph. So here we are, back to the context graph. As you can see, we got some information about an Intel CPU, lots of performance information. We can see things like what socket it uses and how that's related to other information. Lots and lots of information. And we come back here, we have this agentic workflow that's using that data to step through piece by piece a build for a PC using a budget that the user, gave it. So we're now selecting a motherboard based on the build. I've already selected a GPU and a CPU. And this current flow is using Qwen 3.7 Plus. This is all deployed right now in Alibaba Cloud, which I'm showing you, which is why we're going to see models like Qwen Plus, GLM, etc. And we're going to walk through this build. I'm probably getting fairly close to my budget. I am. And we're just going to walk through this, and you'll see we continue to build this out. And depending on how you design this agentic workflow, you can actually have the agent make recommendations. You can, it's actually checking for compatibility. Sometimes it'll flag that there might be some components. It may actually flag that I've gone over budget here, but that's going to okay. I just want to finish this out. And let's just click some of these through. Yes, yes, yes. I know that I've gone way over. Am I almost done? One more thing, and we'll be done here. And I'm going to tell it I'm finished. That's my order total. Yes, I went a little bit over budget. It's going to try to upsell me now, which of course you can design your agent not to, or probably most retailers and brands, let's be honest, will. It's interesting. Some LLMs are more aggressive about the upsell than others, which is another interesting topic we're going to get back to. I'm finished with my build, if I type it right. And that's how you know we're really doing these, because I'm always bad at typing. And we get this button, we could place order. No, this will not place an order, but it could. Now, this panel. This is what makes it a context graph. Well, one thing that makes it a context graph. There's a lot of other pieces to that puzzle as well. But since people have popularized the term decision traces, we see a lot of talk about decision flows. That's exactly what this panel is capturing, is what products were shown in comparison to each other, the customer, which ones did they choose, and then you start seeing things like head-to-head matchups, cross-sell attach rates, all sorts of fun stuff that retailers and brands really, really care about. And we can even start summarizing this with decision context. And then we can even see that this particular product was most popular in a particular price range for a build. We can see that it was most often beaten by that product. And then we can see the most popular cross-sells. Really, really important information if you are a retailer or a brand. But you're thinking, well, I'm not in this whole agentic commerce space. What can I do with this? Well, let's go back out to the main TrustGraph Playground UI and see all the features that we have available to us. And we have this one, document ingest. So you can take your own data. I've taken a few. We're going to look at this particularly. It's an old academic paper about semantic networks. You can see the flow I've created and how I've ingested this, all the parameters that we used, and everything that it output. And let's see, I'm on this collection. That's going to come into effect. It's going to be important in a second. So we come here and we're going to do 3D because people think that's cool, right? Let's see, semantic network. And we can see, yep, we have lots of information about semantic networks. We have the information that's been extracted. We click some of these around and we see lots of things that are connected, not particularly useful for really understanding the data. So what could we do to understand the data? Let's go back. Let's go to the agent query and we could say something, just tell me about semantic networks. And of course, this panel is actually going to have all of the explainable AI features. You see, the graph that's queried will be here. And we see all the different steps that are going through to get to the answer. And we see, wait a minute. There's no graph. What happened? We got an answer. Let's actually trace back. I don't see anything. There's no edges. There's no what happened? Well, if we go here to our agent console, and we start looking at the tools and definitions, knowledge query, of course, is the tool that we need to be able to query the graph, and we'll see, it's only using the default collection, not the academic paper ones, which I created. If we see here, I have a couple of collections. This is the academic papers one. So if I change that, academic papers, and I go down and I click save, let's go back. Let's do the same thing. Tell me about semantic networks. We should see something very different happen this time. So this last time, it just used pure LLM completion to answer the question. So it was using what the LLM itself knew about semantic networks. Now we can actually see, and this is now going to come to talk about this? Maybe it is. So yes, we understand that we made a change to our semantic filtering, which there's actually going to be a lot of updates coming with this. And what it means is that we're now getting a little bit more information in our focusing steps. So we're actually doing a lot of semantic scoring to make this process more efficient. And that's what we're seeing here is if we go through some of these, we'll see where the relationship is in the graph. And we can remember if we click even things like this, this is the actual source for where this graph edge comes from in the original text. So we really get full explainability on where these answers come from. And if we go all the way down here, we can see this answer and how it came, all the steps. And this is the new semantic filtering process, which is much more efficient. It's not using LLMs for the semantic filtering. It's a huge efficiency gain, a huge accuracy gain, a huge precision gain. We're really, really, really excited about how this new semantic filtering process is going to dramatically improve these workflows. So why did I go through all this business of doing it wrong once and then showing you how it actually works with the collections? Because remember how I talked about that word holonic or holon? When we really talk about all the components now of the Trust Graph system, so we have workspaces. This is my workspace for the data I've uploaded. We have retail and space coming soon. We're about to talk about that. And within that, we have collections. The academic paper one is this particular papers collection. If I choose a different one, will this actually work? I'm taking a risk here. Yes, this was a document that I uploaded that didn't have a lot of really interesting stuff, so I didn't really want to talk about it. But it is in there to show you. And as you can see, the semantic network stuff, not in here. Semantic, nope, not there. These are logically separated. So what does that mean? What did I mean when I said holonic? If you've ever read the book, The Ghost in the Machine by Arthur Koestler. I think I'm saying that correctly, or close enough. Eh. He introduced the concept of a holon. A holon is a one to many relationship that is that's really not a really great way to explain it, is it? I've thought about explaining this so many different ways. It's a little bit abstract. I think maybe I should just, you know what? I'll explain it this way because I think about it in three different ways. To me, a holon kind of takes three things I'm really familiar with: fractals, quantum superposition, and relativity, and kind of applies it to information in a little bit. What do I mean? So, what are fractals? Fractals are when you try to decompose something mathematically, the pattern just is infinitely repeating, no matter how far you zoom in. Like one of the classical examples is that when somebody says, well, what's the perimeter of an island? Well, people say, well, it's actually infinite because when you get down with a microscope, there's infinite number of little angles and surfaces on all the crystals and the sand that if you try to measure all of those, it's just infinite. And we go, well, that's not really usable. That's not realistic. How does that help us? So we just we look at it from a macro perspective. Quantum superposition, in that you have all these different states, you have all these different relationships, and they all kind of exist simultaneously until you choose to compare two of them, which gets to the relativistic aspect of it, that again, all of this stuff exists relative to one another. One way that people tend to think about a holon too is in atoms. Like we say the universe is made up of atoms and molecules, so that, I'm made up of lots of things. Hey, stop with the snickering out there. You can decompose it down to molecules, and then you can decompose it down to atoms, and then you can decompose that down to neutrons and protons and electrons, and then you can decompose those down into subatomic particles. But then, if you talk to particle physicists, there seems to be no end to subatomic particles. They just keep going and going and going. We keep discovering new ones and more and more and more. And that's kind of exactly the concept of a holon, is that there's not just one graph, there's not one set of relationships. They all kind of relate to each other, which is why we call TrustGraph holonic, in that we have this ability to create workspaces where data is separated for users. And then within those, we have collections. That's another way to separate the data. And one of the things that will continue to make it holonic is the ability to then, if you need to, be able to transcend those boundaries and understand relationships between those subgraphs. As you can imagine, this seems fairly abstract, and it is. It gets rather complicated rather quickly. So concepts like subgraphs, name graphs, ways of um, some people talk about individual graphs. Um, Again, we think about this all in a singular system in which you have techniques like we have workspaces, like we have collections, like we have the flows for how the data actually flows between all of these, and that's how we actually are able to have lots of different LLMs available in the system. That to us makes this a holonic system. There's currently a W3C community group that's attacking this problem as well. I don't know that they agree with me on the terminology in that particular way, but this will evolve over time. But at this point, this is how I'm most comfortable thinking about it. And it's really kind of the next generation of how we think about graph systems and information systems. And we see this all the time with LLMs. So let's just think about it. We think they're like, we're just going to put a single answer into a single context. And is that really enough information to understand these really, really complex relationships? We oftentimes see no. You need to be able to make comparisons amongst many different data sets. And we know that in a truly large context window, that oftentimes falls flat, which is why people are now looking into graph systems also for efficiencies. So there are so many reasons why people are now looking into this, whether it's for increased accuracy, depth of insight, or just by making the system more efficient. Let's jump to another workspace that we have. And this one is called Space. We've taken some data from various NASA missions. Let's see, what's the one I've been taking? Oh, that's right, Voyager. I've been talking about Voyager 1, Voyager 2, and I'm on the wrong collection, as you can see. So that's not going to show me much. Let me back out and I'm going to have to do a refresh, make it happy. Let's see, this one's going to be default in this space. We can see we have the graph loaded. Again, you know it's real because I keep screwing it up. I really didn't mean to do that. I wish I could say it. I meant to do that. No, I didn't mean to do that. I meant to do it right the first time. Voyager 2. And here's some information about Voyager 2. Let's see what we have there. Different kind of flybys, some interesting information, and it looks pretty. And we even have another, if we go here, visualization. These are some of the other ones. Where is it? Where is it? I'll find it. There it is. I should have done this beforehand, probably, instead of having to force it to load right now. And we can see, again, using the TypeScript libraries in TrustGraph, these are the sort of visualizations that you can make from these agentic workflows. And we can see Voyager 2, we have some information. We click on all these, we can actually see it through the solar system. Isn't that pretty? Isn't that nice? Isn't that nice? And we can see how it compares to other ones, Voyager 1. Lots and lots of cool visualizations that you can do now once you have the TypeScript libraries that enable you to very quickly create different kinds of agentic workflows and visualizations. So we have some data. So same thing. Why don't we go back and we can see, again, the same thing. Agent query, tell me about Voyager 2. Well, we'll get back to that second. Let's just see. I want to do this. What model are we doing? Oh, I forgot to change the flow. So this is actually using one of the flashes. I actually don't remember which one. So we'll see the process that it goes through. And I haven't used this model in a while. So again, another mistake that we're going to work through together and see how it does this. Yeah, it doesn't seem to have captured quite as much because this is one of the flash models, which again, this is why we have these explainability features to see how the model worked through this. So what did we get here? It did a pretty good job, though. We're actually seeing the stuff that's really in the graph. And a lot of this is because of the improved semantic filtering algorithm. So if we go back and we go to Voyager 2, we can see this is pretty much the information that it retrieved, is this information on these flyby events. Yeah, we go back, that's pretty much what's here. And we could go through and do it again, but let's do it again in a different place. So if we go here, it's a good time now to talk about, some of the features that we have here. So we have the ability to ingest your own data, like Context Graph Explorer, which you have to have ontologies loaded to get this, and you get this, and you go, "Ooh, isn't that cool?" It's like, well, yeah, I guess, but what are you going to do with this? I don't know. Tell us in the comments down below if you have an idea of how to use this. We don't typically use these for knowledge exploration, but we know some people do. That's just not, we don't tend to do that. And when I say we, I mean me and Mark. So I guess I should say that. We is pretty singular, as in two people. So let's look. So this is the agent query. And this is the graph navigator, which is looking at from a more traditional graph perspective, which actually I do like to use because of the natural language search. Again, I can go to stuff about Pioneer missions and get a little bit more information about that. That's a pretty nice way of doing that. But when you're designing agents, and you'll notice that we haven't really done a lot of detailed design here, and we've done that on purpose so that you can play around with this yourself and see how the system changes. One of the really nice features that I like is this ability of testing. So if we go here, we can actually debug this agent. So let's change the model. Let's see what GLM does. This is GLM 5.2. So tell me about Voyager 1. I want to know about Voyager 1 this time. And this is going to give us, again, if I'm on this panel, we'll still see the answer. we're not going to see the actual graph. What are we actually going to see? We're going to see the tools that the agent is using. We're actually going to see how many tokens went in, how many tokens came out, latencies on the LLM calls. Why would we want to do this? Because if you're designing agentic systems now, you know how important context efficiency is and token efficiency is. So these are things that are really, really important now. And there's so many things we can talk about with this just aspect alone is the ability to talk about just small tweaks to each one of these definitions. For instance, like these, if you have skill files, they can go right here. And all of these, just very small tweaks can either make the flow faster, more efficient, fewer tokens, so many different capabilities that these tools can help with. What else do we have? We have an ontology viewer so that you can see the ontology that we have loaded in the system for this data. And I should have clicked on this earlier because it's taking a little bit longer to load than I wanted to. I know it's there though. I know you're there. Don't tell me you're not there. Sometimes we have to do a little bit of a refresh to get it to wake up. See, it was there. It just, again, this is a test suite, really, of tools so that you can see all the capabilities. I wouldn't use this UI for production. Although, again, when you deploy TrustGraph open source, this UI comes with it. And we can see the ontology that we have and even tools for working with that ontology. If you've worked with ontologies in the past, you know there aren't a lot of great tools for working with them. Now you can build and modify your ontologies in a nice UI. Or you can just, as you can see, if I go back, you have the ability to import them directly as well. So, what are some other features that we have? I haven't even talked about the structured data, but we still have that as well. SPARQL queries. This one could be pretty useful. So one thing we have in the system is anytime in the demo now, you might see things like examples. So you'll see different example queries here or presets. So what's a good preset that I want to do? Well, I guess we'll just do this one. So it actually generates the SPARQL query that you would need to get this information. You click execute, and you're actually going to see the SPARQL query execute and pull information from the graph. Now, why would you want to do this? Well, let's look at another one. If I actually go to the retail workspace, and let's see, did those automatically change? They do. What was a good one? There was one that I really liked, and I gotta find it. What was it? You would think I would remember this at this point, but I've already forgotten. Um, Maybe it was that one. Well, that one seems pretty fun. So, and I actually don't remember doing this one, so hopefully this one actually works. Yay, it worked. Woo! Yeah, this is what happens when you do it live, folks. Why would you do this? Well, if you have common patterns that you're designing into your agentic system, maybe you think, well, do I want to create these sort of queries every single time? If I'm doing this very, very frequently, then maybe all I want the agentic workflow to do is to have these templates available to it where it's just going to replace some of these variables with what the user is looking for, which will make this system much more deterministic. So we're just giving you all those options and giving you all the tools to see every single element of the system that is available for performance improvements. And perhaps that's a really good time to segue into. Well, I just want to quickly mention we do have the different flows, the different models available. The playground preview that I'm showing you right now again is running in Alibaba Cloud, which is using models like Qwen 3.7, Qwen 3.6, GLM 5.2. Many of those are open models that you can deploy yourself. And why is that important? I've talked a little bit about efficiency, about token efficiency and just general cost efficiency, as we're seeing now that the biggest ROIs from agentic workflows are in the most complex task where you need to be able to understand complex information across silos. Again, remember how we talked about the idea of a holonic system being able to create multiple frames of reference within a larger data environment? All of these things are kind of coming together at the same time, aren't they? Well, how do you make it more cost efficient? I think one of the most important elements of the trust graph stack that gets really overlooked is our full element inferencing stack. Now, this particular demo that I'm showing you right now and the playground preview that you're going to be able to get access to if you click the link down below are using the serverless deploys in Alibaba Cloud. However, that is subject to things like availability. You might need provision throughput, which is another discussion. If we want, we could talk about that a little bit, what provision throughput really is. Maybe I will. Um, do I want to talk about what provision throughput is now as I segue into this topic? Sure, let's do that. So, what is provision throughput? Pretty much all the clouds now, if you want guaranteed access to a LLM, you have to buy provision throughput, which is a little odd in a lot of ways because, isn't this supposed to be serverless? Don't all I need is an API key and I get access to this model? Well, if you've actually deployed a lot of infrastructure and agentic workflows within the major clouds, this isn't how it tends to work. Without any sort of provision throughput, you get either 429 errors, retries, timeouts, throttling, and just in general, you have a bad experience. So you get pointed to, we don't have quota increases anymore for LLMs. You can get pointed to buying provision throughput. Now, many years ago, when provision throughput was first announced, I thought, well, are they deploying a model specifically for you? And that's how they're guaranteeing that level of service? And the answer to that is no. That is not what's happening when you get provision throughput. Now, some of the clouds will, like for instance, Alibaba Cloud actually has a tool, I think it's called PAI, where you can deploy a model that you control yourself. But that's not provision throughput for the serverless models. So what's actually happening? How can they provide you guaranteed access to a model if it's not your model and you have so many people trying to access it at the same time? Now, I don't know this for 100% certain, but I very strongly suspect this is what's going on. Do you remember a while back when we were talking about data streaming tech, we talked about QoS, quality of service, and how you can have multiple tiers of QoS? I strongly suspect that they're using a networking protocol or architecture in which they have multiple QoS now for access to the LLM. So they're going to have many instances of these models running. They have load balancers. They have an architecture that's switching between them depending on demand. And depending on what QoS level you have, that kind of determines what access to the model you get. And if you haven't bought provision throughput, you're at that lowest level of QoS, which is essentially if it works, it works. If it doesn't, sorry. And then you go up the rungs depending on how much how much QoS you've actually purchased. Now, if you're thinking, well, QoS, that's often a term that comes from, for instance, safety critical architectures, where you're architecting the avionics network for an airplane, where you know exactly how many um, objects are on the network, how many devices are on the network. Well, you pretty much, I mean, even on a commercial aircraft, when you have the infotainment system, you know the maximum number of passengers that are going to be in the cabin. So even with something like that, you can very, very well define the limits of how much network capacity we'll need. But when you get to the really important things like the flight control system, well, that doesn't vary. The aircraft doesn't vary. It's the same from flight to flight. So you can really design around these QoS parameters so that you have the fixed number of devices and you kind of go down to the ones that maybe vary a little bit. You can plan for that. Well, how do you plan for that when you have very variable demand depending on customers for these sorts of models? Well, they're going to have to scale up and down quite a bit based on their demand projections and their cost budgets and their cost goals and their revenue goals. So this is like a constantly sliding scale, which you can imagine they're probably going to get wrong. Well, maybe not wrong, but it's not going to always be where the user wants it to be. And what that means is that if you're depending on this provision throughput, there are going to be times where it's probably not going to perform to your satisfaction, which The cynic in me says they'll probably tell you to buy more provision throughput. If you're an enterprise that has gone into this, please let us know. But there is an answer to this. And the answer to this is something that, again, I'm recording this on July 4th. Just this week, Alex Karp from Palantir and NVIDIA, well, I guess Alex Karp said this, and NVIDIA kind of echoed it, not in the same way, that you want to have control over your AI cost and your data. You have to control the models yourself. And we fully agree with that. That's why TrustGraph has a complete LLM inferencing stack that can deploy models that run on NVIDIA, AMD, and even Intel hardware, so that everything that I've shown you today, the holonic context graph systems with the ability to separate data spaces in workspaces, the ability to separate data within those workspaces with collections, and the ability to create workflows with multiple models, all of that in a containerized package that can then take a model like GLM 5.2 or Quinn 3.6 or Gemma 4 or even the Nemotrons, any open model, and you can deploy one, two, many of those with different flows that are all in a system that's a completely holonic, agentic context graph system that you completely control from your data to the models, which means you don't have to count tokens anymore. Because if you control the model, the only thing that matters is the compute. So that if you have the compute necessary to run it, you don't have to count tokens anymore. And these are all the things that we have really designed TrustGraph for since day one. We have had the strongest of convictions going all the way back to 2023, really. And I'm sure you can check my social media because I've griped about these things many, many times. We've had the strongest of convictions going all the way back to 2023 that these were the things that would really matter when enterprises started really deploying AI at scale. And that time is now. If you need to make your agentic workflows more efficient, whether it's tokens, whether it's owning your own data, whether it's owning your own models, or whether it's getting more accurate answers, or just even understanding where those answers came from, TrustGraph solves all of those problems. And now you can test it out without having to deploy anything, not a single line of code. You don't even need to import any Python libraries. All you have to do is click the link down below, tell us who you are, tell us where you want us to send you the information, and you'll be able to get access to this system.